Hi, this is Shoham with the Yelp recommendation engine, and this is the explanation of the project with the slides. So the Yelp dataset is an open dataset that was released in 2018. It has 7 million reviews, and it's a big dataset. And so what I'm doing is trying to statistically reduce the data size rather than setting a specific location or time range that I'm trying to look at the data for, and then creating a collaborative filtering recommendation model from that. What I do for statistical subsampling is I find what an average person is and find what an average business is on Yelp, and that already cuts down a lot of the data. And then I also use what is an average review and cut data further. And then for the recommendation system, I use a value decomposition alternating least square algorithm, which basically just creates latent space matrix from the business and the user matrices. And it predicts kind of what is missing from that matrix. Basically reviews that have not been made, it tries to predict what those reviews would be like. The tools that I use is Spark, Python, Colab, and ngrok. Spark clearly for doing big data analysis, and then Colab because that's a compute that I can use for, I pay for the pro version, and then Python to code it all, and then ngrok to tunnel into the Colab Spark session. Let's see, what is this one? There's a review period. So these are the tasks that I did. I review the previous systems that have tried to use the Yelp dataset. I haven't seen anyone that did it statistically, so that's why this project is unique. I review other exploratory data analysis done on the Yelp dataset, and then I run my own exploratory data analysis, train the initial model, and then I add the sentiment analysis, see how that performs relative to without sentiment analysis added as a super score, and then I fine-tune the recommender model to get the best performing one. With my exploratory data analysis, I can see that most users leave 3 to 4 reviews, while some leave 3,000. Most businesses get around 45 reviews, although some can have 8,000 reviews. And so I decide how to cut the data down from that, saying I want reviews from users between 10 and 50, between 50 and 100 reviews per user, and businesses between 100 and 500 reviews per business. So when I add the sentiment analysis and create a super score, this is the result that I get with a subsample of 1,000. And you can see that it's actually having a bigger error than it without adding the sentiment analysis and creating a super score. And so this is why I stick to not adding the sentiment analysis and running on the big data, running it without that for the best model. And so my best model has a rank 30, max iteration of 20, and a regularization parameter of 0.2, and gets a root mean square error of 1.115. These are some examples of what the best model performs with. And this is on more than 200,000 reviews. So you can see this error is much better than this error, but that's just because it's running on more reviews, right? It has more data to train on. Rather than 1,000, here it has 200,000. That's kind of the power of big data in this case. And that's it. And I'll put my video here when I turn in the slides so that you can review it. Thank you.